All right, so we talked about what concentration is, kind of as a quantitative value, and then different types of concentrations that we'll encounter. And now we're just going to spend the rest of the time doing some practice problems together on concentrations. So like converting concentrations and also using a concentration value to figure out how much solute is getting delivered or what volume is needed to get a certain amount of solute. All right, let's go to that slide. Okay, so here's the first one. Isuprel is used to treat asthma, is available in IV form as 4 milligrams per 500 milliliters of solution. What is the concentration of this solution in milligrams per milliliter? Okay, so I included this question here because this actually trips up quite a few students. They're trying to figure out, use some sort of concentration given, and this is actually the simplest problem. Remember what is it milligrams per milliliter mean? How many milligrams there are per milliliter of solution. And so to figure that out, all we have to do is take what we know as 4 milligrams over 500 milliliters. And so it's 0.008 milligrams per milliliter. So again, just finding concentration is taking solute over or divided by volume. Um, so isoprel can come in other concentrations too, right? So here's a label which is zero point 0.2 milligrams per milliliter. So this would be different, right? And I found another label that actually says more. It says 1 milligram per 5 milliliter, which, right, if we were to do what we did before, 1 over 5 is zero point 0.2, and then the units combine to milligrams per milliliter. And so we see how these two things are the same. So it has both um, on the label, right? Or if we had, let's say 500 milliliters. Well, this is kind of getting ahead, but let's do it. This is going to be like the next question. But if we have concentration, and it can be written in either of these forms, right? 1 over 5 or zero point 0.2 over 1, and we had 500 milliliters, how many milligrams would be in there? How many milligrams of isoprel? So now we can set it up like a conversion, right? Because now we have the known quantity is 500 milligrams, and our conversion factor would be zero point 0.2 milligrams per milliliter. And so milliliters cancels out, and we get 100 milligrams of isoprel. And we see that 100 milligrams now per 500 milliliters would get us back to that zero point 0.2. 0.2 again. Okay, just kind of thinking of it in different ways. Okay, here's another question, which I think is kind of like what we just did. An aqueous solution of glucose has a concentration of 9.9 milligrams per deciliter. What's the mass of glucose in milligrams in 3.5 deciliters of this solution? Okay, so actually this is exactly like what we just did. Different thing or different substance and different numbers, but we have a concentration of 9.9 milligrams per deciliter. So even though it's written as, sometimes we write it like in a line like this, deciliter. Whenever you're doing a conversion, do it as a, a ratio, an up-down numerator-denominator ratio. just so we can keep track of units better. Okay, and then we also have 3.5 deciliters as the volume, and we're trying to find milligrams, and so we know what to do, right? We can set this up. Like so, where now deciliters cancels out, and we get 34.65, but don't forget sig figs, which should be 2, so we would say 35 milligrams. Right, and think about if you had 1 deciliter, you'd have 9.9. We have 3.5 deciliters, so it should be something bigger. This is again like the idea of checking at the end of a question. Does this make sense? Okay, let's keep rolling. Since you can pause it and think about this more, or take the time you need. I want to get through another one. And again, uh, you can pause it before I start working and see if you can do it on your own. Here's another one. So a doctor orders 25 milligrams of lidocaine to be given to your patient by an IV. The IV lidocaine solution available has a concentration of 4.00 milligrams per milliliter. How many milliliters of lidocaine solution should you administer to your patient? Okay, so we have milligrams, we have a concentration, and we're trying to find milliliters. So this is a little bit different than the last question, right? It's looking at it from the other way. Last time we had a volume, we want to know how much solute. Now we have a known amount of solute that we want. How much volume do we need? So we're still going to always start with the known quantity, and then we'll adjust the conversion factor as needed to get the result. So here we need to flip the concentration, right? We have 1 milliliter contains 4 milligrams. So we end up with milliliters, and we have 25 divided by 4, and so 3 sig figs, 6.25 milliliters of solution would need to be given. Again, does this make sense? If you had 1 mil, you'd only get 4 milligrams out of 1 milliliter. You need 25, so it's going to be something more than 1. Okay, so there's more questions like that in your textbook. Page 270 has practice exercises, and then of course the back of the chapter has more, and sapling. Let's look at some percent questions. Remember that percent MV always involves grams and milliliters. Oops. So we want to calculate the concentration in percent mass volume of a beverage that contains 28 grams of sucrose and 315 milliliters of the beverage. To find, remember this from your notes, percent mass V, take grams over milliliters times 100. So here, right, we can just take 28 grams over 315 milliliters times 100% equals 8.8 repeating, so 8.9%. So when you drink a can of soda, it's 8.9% of it is just pure sugar. That's cool. That's cool. And if it's something like Mountain Dew, it would be even more. Okay, here's another one. This I have a question for you. You might know this, some of you. So the most common IV solution is physiological normal saline, or called NS. Do you know what the solute in NS is? And it has a concentration of what? If you don't know this, it's okay, but I figure some of you have probably encountered this before. So normal saline is sodium chloride, and it has a concentration of 0.9%. So maybe you've seen a bag like this. Just call it saline solution, or NS, or normal saline, or physiological saline, but it's 0.9%. Okay, so let's say you've been asked to prepare 500 milliliters of normal saline. How many grams of sodium chloride should you weigh out and add? So let's remember what 0.9% means. So remember, to find it, we had grams per milliliter times 100. But if given, it would be 0.9 grams over 100 milliliters. Because so 0.9% means 0.9 per 100. Right? So this is how we want to use it in our conversion here. So now we have 500 milliliters. We have a concentration. And we want to find grams. And so as written, we can just multiply, start with the known quantity, times concentration. Milliliters will cancel out. And so if we take 500 times 0.9 divided by 100 is 4.5 grams sodium chloride. So if you wanted to make a half liter, a 500 milliliter solution, normal saline, you would need 4.5 grams of sodium chloride. Okay, what volume in milliliters of normal saline solution contains 2.5 grams of sodium chloride? So 500 milliliters has 4.5. We just solved that, so it's going to be something less than that. But let's work through it as if we didn't know that already. But we do know that, so we can use that to check at the end. Okay, so normal saline solution, 0.9%, right? So we want, or we know 2.5 grams. Concentration is 0.9 grams per 100 milliliters, and we want to find how many milliliters. So we start with the known quantity, and then to get milliliters, we're going to flip the conversion, or we're going to flip the concentration. So we have 100 milliliters per 0.9 grams, and so grams cancels out. We take 2.5 times 100 divided by 0.9, gives 277.7 repeating. And so this would be 278 milliliters. All right, and I think that's the last question I have. Yeah, then there's more in the book that you can work through. We did a molarity question when we introduced molarity, so I didn't put one here at the end, but those are there too. Next time we'll get more. We kind of hinted at this already, but we'll get more into like dosage calculations. So we're going to extend. Here's like a concentration of some medication. Your patient needs this amount per kilogram of body weight. How much do you give them? Things like that. Okay, so but make sure you understand concentrations and all of these conversions we've done before we move on to that part. So until then, take care. Hope you're well, and let me know if you have any questions and how things are going. Okay, bye.